Good morning, children. Today we are here to discuss Unit 9. What is inside atom of 9th class? In previous class, we have started atomic models. Among the atomic models, we are having three atomic models in 9th class. One is J.J. Thomson atomic model. Second one is Rutherford alpha scattering experiment or Rutherford atomic model or planetary model. Third one is what? Near Bohr atomic model. Among these all models, in previous class we have completed Rutherford J.J. Thomson atomic model. According to J.J. Thomson atomic model, what is said? If atom is in spherical shape, in which what happens that positively charged substances particle will be covered throughout the atom, in which electrons are embedded. Electrons are embedded within positively charged particle. By default, atom is neutral. It was the concept explained by J.J. Thomson. To overcome the drawback of J.J. Thomson, he explained that particular concept that the atomic mass of an atom is covered throughout the atom, in which by means of positively charged particle called as proton. So that within the particular positively charged particle, electrons are embedded uniformly existing within that particular positively charged particle. Due to that reason, atom is neutral, but practically he could not even clear justification. To overcome the drawback of J.J. Thomson atomic model, his disciple, J.J. Thomson disciple named called as Ernest Rutherford, performed one experiment. That experiment is called as alpha scattering experiment. Based upon that alpha scattering experiment, he has given a name, a atomic model that is called as Rutherford atomic model. In the year 1908, to perform this particular atomic model, he has taken two things. First one is a circular gold foil he has taken. Other one is what? Alpha scattering particle he has taken there. What is called as alpha scattering particle? If I go for alpha scattering particle, helium consisting of 2 electrons and atomic number, whose atomic number is 4, in which 2 electrons are existing there. If it is losing these 2 electrons, it forms helium 2 plus ion whose atomic number is 4, where negatively charged particles are totally evacuated from that particular element. This particular one is called as nothing but what? Alpha scattering particle. Alpha particle which has high energy, more amount of energy is enloaded within this particular alpha scattering particle or alpha particle. That alpha particle he has taken as well as gold foil. I have taken only one gold foil. It is a gold foil. These all rays are nothing but what? Alpha scattering rays, alpha particle rays, in which high energy particles, we can call it up there itself. They has taken that particular alpha scattering particle. Then afterwards, what he did? He placed this particular gold foil in such a way, is placed in a detector region. Around this particular one, a detector region has been placed. What is the duty of this particular detector region? When the rays are incidenting on the surface of that particular one, it shows some flash of light. It will show some flash of light. It will will show it up. By that we can identify that the rays, whether they are passing to the particular gold foil or not, easily we can identify clearly in which direction the rays are reflecting. Everything, whether the rays are passing through atom or rays are reflecting back or rays are deviating with an angle, etc. so on, all can be seen as the rays are incident in a different spots. Then you want a flash of light. By the particular flash of light, we can identify that. That is nothing but what we can easily identify what is the nature of a particular, how the atom is existing. We can understand clearly. So this total arrangement has to be done in what? Vacuum, where there is no air. Where there is no air within that region, we have to perform this activity. First of all, what he realized, as J.J. Thomson said, that the whole atom consisting of positively charged particle, within that electrons are embedded. So, if it is an atom there, on the surface of this one, if I am allowing alpha particles to be get incident, then what happens there? All alpha particles are what charged particles? Positively charged particle. Nucleus is the atom is also totally covered with what? Positively charged particles in which electrons are embedded. As electrons are embedded in between positively charged particles, alpha particles are positively charged particles. Positive, a repulsion will be taken place. Due to that repulsion, maximum number of alpha particle rays will be deflected back. He thought in that particular way that maximum number of alpha particles will be deflected back away as whole atom is covered with the positively charged particle, according to J.J. Thomson. But what happened there? He observed that, what he thought, based upon his thought, the concept has been not taken place. He observed that some alpha particles are passing to the particular atom. He gets shocked by seeing it up. Merely if he is sending 2000 alpha particles to be get incident on the surface of a gold foil, if it is an atom, among that only 1 or 2 alpha particles are deflecting with slight angles. Maximum 99% of alpha scattering rays are passing to a particular atom there. He gets shocked. What is there? The whole atom doesn't exist a positively charged particle. He gets shocked and he identified that the whole atom is not existing with positively charged particle. It is having maximum of empty space. As maximum number of alpha particles are passing through the particular atom. Out of 20,000, 1 or 2 alpha particles are deflecting here. The deflection means what? As they are incidentally, they are deflecting. As they are incidentally, they are deflecting away from a direction. That itself. By that, he understood that atom consisting of a lot of hollow space, empty space. That is nothing but what atom. That is the point he identified. The space within an atom is remained hollow, empty, or hollow space, but atom is stable. That was the point he has given there. Based upon what property? Maximum number of alpha particles are passing through a particular gold foil. We have seen 20,000 alpha particles if allowing to get incident. Out of 20,000 alpha particles, 1 or 2 particles are deflecting away. That is first point he observed there itself. Second point, we started up. 1 or 2 particles, alpha particles are deflecting there itself. As they are deflecting means what? They are deflecting from the region. Means where they are incident, why this deflection is taking place? Why this deflection is happening here? Means there must be consisting of a positively charged particle. Why? Alpha particle is positively charged particle. If positively charged particle, repulsion takes place. Due to that reason, deflection can be taken place. Therefore, there must be consisting of a very huge size, a very large size positive charge of mass concentrated within an atom. Inside an atom, there is a region where positively charged, a large positively charged particle of mass concentrated within an atom. He identified depending upon the alpha rays deflected back there itself. Based upon that. That is second point we can give it up. Third point. What this third point gives there itself? All positively charged particles in an atom, we have seen it up. All positively charged particles within an atom form a small density region. This is the region we call it up. This region is called as what? A small density region exactly at center, which is called as a nucleus. In this particular nucleus, two particles will be existing. One is proton, other one will be neutron. Where proton is positively charged particle, neutron is neutral charge. Mass of that particular atom can be identified by proton plus neutron. We have already seen. And electron mass is negligible, whereas proton mass is quite equal to that of neutron mass. Therefore, the total atom mass, atomic mass of an atom can be identified by two different particles, that is fundamental particles called as proton and neutron, which are existing within the nucleus, which gives mass of that particular concerned atom. Proton and neutron together is called as nucleons. What we can call them as? Nucleons, we can call it up. That is the third point what we can give it up there. Fourth point what he said there itself, he said that only proton and neutron are existing within the nucleus, whereas electrons are not existing within the nucleus. Then where does those electrons are existing? Those electrons are existing outside of the nucleus. On this particular board file they are existing such that these electrons are orbiting around the nucleus. These electrons are orbiting around the nucleus. In what way? Like planets within a solar system, we take it up around sun, remaining all planets how they will be orbiting. In the same way, the number of electrons in specified orbits, in circular orbits, they will be orbiting around the nucleus. This phenomena was explained. This particular point he had given as electrons are existing outside the nucleus and revolving around the nucleus, like planets orbiting around the nucleus. Based upon this concept, this point, he identified this particular Rutherford atomic model is also called as planetary atomic model, also has planets revolving around the sun. Similarly, electrons orbiting around the nucleus. In that particular way, he has suggested that planetary model in unit fourth point we can give it up. Coming to fifth point, when it comes to the size of this particular nucleus, size of this particular nucleus is very small than that of size of an atom. Size of the nucleus is very small than that of the size of an atom. That particular point also he has given. These four postulates had been explained by whom? Sir Ernest Rutherford in his experiment called as alpha scattering experiment, or Rutherford atomic model, or planetary atomic model also we can call it up. This Rutherford atomic model also existing of certain limitations. What is that limitation? If I am taking hydrogen atom atomic number is 1. Mass number is also equal to 1. It consisting of one proton, one neutron, one proton and one electron. An electron, we know that proton is positively charged particle existing in the nucleus. If I am taking proton is a positively charged particle existing in the nucleus, electron is orbiting around the nucleus in specified orbit. As electron is orbiting around the nucleus in specified orbit, as electron revolves according to classical law of thermodynamics, any object or any particle, if it is orbiting around the nucleus, what happens there? It radiates energy, it gives out energy there itself. Energy will be get lost. As it is giving out energy, it loses its energy. If it is losing its energy, automatically what happens? The electron which is orbiting in orbit, what happens slowly? It comes closer to the nucleus and it will fall into the nucleus. Fall into the nucleus. If it is falling into the nucleus, atom will be get collapsed. But we know that atom is stable. Atom is stable. But he could not give any justification for this particular drawback. Due to this particular reason, a new atomic model came into existence in the year 1913 by a Danish physicist named called as Niels Bohr. Whereas Rutherford belongs to New Zealand, whereas Danish physicist, he belongs to what Niels Bohr of Danish country, Dutch country. In the year 1913, he performed another atomic model. That atomic model is called as Bohr atomic model. Within that particular model, that model came into existence to overcome that, to rectify the drawback of Rutherford atomic model. By this we have completed our concept called as Rutherford atomic model. Children, try to analyze this concept. Try to revise this particular concept, watch this particular video number of times, so that if any doubt is there, can be rectified and be well prepared and analyze the concept and well prepare for exam. Thank you, children.